The graph of an exponential function looks something like this if our base a is greater than 1, and it looks something like this if our base a is between 0 and 1. And some properties of exponential functions that we can talk about based on these graphs is, first of all, the domain of any exponential function is all real numbers. But in both of these situations, our graph stays above the x-axis, which tells us that the range is just 0 to infinity, only positive numbers. And also in both of these situations, our graphs are getting closer to the x-axis, in this case as we go off to negative infinity in the x values, and in this case as we go off to positive infinity for our x values. We're getting closer and closer to that x-axis, but we're never going to actually touch or cross the x-axis, which means that the x-axis serves as a horizontal asymptote for these functions. And then also because we never touch or cross the x-axis, we don't have any x-intercepts, but we do have a y-intercept in both of these cases of 0, 1. So each of these points would be located at 0, 1. So now in order to figure out more specifically what a graph would look like for a specific base a, we're going to plot points, plug in numbers and plot points. So we first want to figure out what the graph of f of x equals 2 to the x would look like. So when I plug negative 1 in for x, 2 to the negative 1 is the same as 1 over 2 to the positive 1, or 1/2. When I plug 0 in for x, 2 to the 0, anything to the 0, is just 1, and then 2 to the first is 2. So now I'm going to go to my graph paper and plot this collection of points. So we've got negative 1, 1/2, 0, 1, and 1, 2. And then connecting these points with the shape that we saw up here, we end up with something that looks like this for the graph of 2 to the x. G of x equals 1/3 to the x. Again, we're going to do the same thing, just plug in some different values for x and figure out what the corresponding y value is. So when I plug a negative 1 into this exponent, 1/3 to the negative 1, the negative exponent would flip it, which would give us a 3 to the positive 1, or 3. Again, anything raised to the 0 power is just 1, and then 1/3 to the first would be 1/3. And now we're going to plot these points. Negative 1, 3, 0, 1, and 1, 1/3. And then we connect these and end up with something like that for the graph of g of x.